example number 3. This is example number 3. Well, this is equilibrium torsion, L section, L section, L section, this is L section, L section, equilibrium torsion. The torsion, this means that the torsion cannot reduce it in any way. What is the difference between this example and first example, example number 1, is we have here L section. We have a part of the slab participate in resisting torsion. بشكل سلابك بجدار أبي للresisting torsion. This is the difference only. The only difference. The slab thickness HF 150 millimeters. Here the same dimensions. BWeb 400 millimeters. This distance is equal to 700 millimeters. Reinforcement 1, 2, 3, 4, 5 is similar to the previous examples. We use 5, 25 millimeters. Here we have 2, 5, 12 millimeters. The stirrups here is also given. We use stirrups 5, 10 millimeters. Stirrups we use 5, 10 millimeters. Now I go to check the section for shears. We pass through the same procedure that passed in the example number 1. Design for shear. Step 1. This is the step 1. This is second to step. Check. Shear reinforcement is needed or not. Needed or not. Same procedure. VC, as we know, phi VC over 2 must be greater than V ultimate. Must be greater than V ultimate. Must be greater than V ultimate. Here, same VC, same phi to the example number 1. Then therefore phi is equal to 0.75. The shear did not depend on the slab. On this part, does depend on the beam shear. Therefore, VC is similar to the first example, is equal to 2 to 9.12. VC همانشتا شو كان همانشتا بو بيما كمان اعتمادك على سر بيما كمان اتمناك على سلابك بو همانشتا l'example number 1. To start with 0.12 example number 1 وهذا is equal to 86 kilo Newton. Applied V ultimate applied 215. Therefore, design for shear reinforcement is required. Design for stirrup is needed. This is the first. Now I check the design for torsion. I check the design for torsion. I check the design for torsion. I go to step number 3. Check torsion reinforcement is needed or not. Torsion enforcement. Before I do this check, it's required to know the dimension of the slab that's participate dimension of the slab or a fraction of the slab Let's participate, B flange. Let's participate in the torsion, resisting torsion. شنك ليرة يكسانا is equal to this is 150 AGF is equal to 150 و this distance totally حفصت و BHB بيان HB is equal to حفصت minus 150 فكاتب بيان 150 إذن HB بيان 150 this is less than or equal must be less than 4 AGF. AGF is equal to 4 AGF. AGF thickness of slab كاسة بانجا إذن شصت ملي less than بيانصة بانجا ملي. إذن okay. إذن AGF this distance B flange is equal to شصت millimeter. شصت millimeters. We can use now شصت millimeters. Now I go to find ACP or PCP. شصت 150 400 حفصت 700 millimeters. Now I put x1, this is x1, this is x0, this is y0, this is y0, this is x0. 600 x0. Now I try to find A closed parameters, as we know is equal to summation x0 y0. أكاشان 400 times صفصت زائدا شصت times 150 شصت times 150 is equal to ACP is equal to شصت زائدا 150 غلط هيك لأن نسيني محاضرات كان بس والله شاكي كرا تو شاكي كرا كاتب 400 مليمتر 3400 مليمتر تو زي غلط هيك لحساب لشيتك رقم هيك غلط دان راه إذا المهم close stirrups شصت في 150 شصت في حفصة this is clear this area times this area times this area. Now I try to find PCP ACP و PCP. Sorry. This number is correct. Is equal to say 370,000 millimeter square. 370,000 millimeter square. Now in PCP we have some error. Akachan 400. This equation is equal to summation x0 plus y0 summation x0 400 plus y0 حفصت. This is parameter. Go through this line, external line. Go through this line. What we do there? شصت زائدا حفصت times 2 plus شصت في 2 is equal to 3,400 مليمتر. 3,400 مليمتر. غلطة كاليريا 3,400 ما نسمى دان 3,400 مليمتر. Now I can use T-Crux equation 0.33 lambda FC prime ACP square over PCP. Now substitute 0.33 times 1 times 28 times ACP 370,000 over PCP 3400. This is equal to T-Crux is equal to 70.3 kilo Newton meter. Now T ultimate must be less than 5 T-Crux over 4 phi is equal to 0.75. Phi is equal to 0.75. T crack times 70.3 over 4, and this is equal to 13.2. We get some resisting, some small resistance relative to بالنسبة per area relative to the first example. If we added or participate the slab portion in the calculation of torsion, we have some difference, some little difference. Therefore, and T is equal to 52. This is therefore it's required. This is more than this. It's more than this. This is therefore design for torsion reinforcement is needed. Torsion reinforcement is needed. Design for torsion reinforcement is needed. Now check the section for shear, section strength for shear. Now I check the section stress for shear. It is similar to the previous example. We found Vs similar, exactly similar to the previous example. We found Vu, we have Vu, we found Vs is equal to 103.9 to example number 1. I mean example number 1 kilonewtons, and Vs is less than 0.66 Fc prime BWT, and is equal to 890.6 kilonewtons. Vs is this. This is the section is adequate for for applied shear. Is adequate for applied shear. مناسبة reasonable for applied shear. مشكلة معنية applied shear. يعني ناوي قوري كينو اعتيادية تواني بكاري بين. Now the same idea 5. I check the section. خلاص كم رنجي خنا اختار قالنيها برو قالينا روح. Now I go to check the section strength for shear and torsion at the same time. Here just for shear. Now for shear and torsion at the same time. Check. The section strength for shear and applied torsion at the same time. We have the equation there. Come on here. It's required to find x1. We have x1. Stirrups, I put the stirrups there. If we take the slab into consideration, we must put the stirrups inside stirrups. Inside the slabs. The distance from here we take until this point, until pass to the center of the stirrups, Azani how much? 15 millimeter. As we know, this distance is 45 millimeter. As we say previously, is equal to 645 millimeters. This distance. Previously, this is 600 plus 45, 600.55. Well, here is slab. X1, this distance. Well, this distance X1. Y1, sorry. Let's say this is x2, well, this is y2. x1, x1 is equal to chan 400 minus cover 45 at left minus cover up to center of the stirrups 45. This is equal to 300 millimeters. Y-axis 700 minus 45 from here to center of the stirrups 45, from here to center of the stirrup 45. أكاد شصته the millimeters. Now x2 equipment 600 plus 45 أكاد 645 millimeters. y2 is equal to here slab. The cover in the slab normally we use 20 millimeters. The cover of the slab normally we use 20 millimeters. إذن ألينشي 150 edge minus 20 at top minus 5 over 2. This at top. At bottom also 20 covers minus 10 over 2. This means that from the extreme fiber to center of the stirrup is equal to 25 millimeters. لركعة شنو كان جنبليم in slab cover is 20 cover is 20 إذا أكاتا بس 2 millimeters. إذا here is equal to 100 millimeters. Now it's easy to find A not edge. أكاتا summation x1 y1. x1 300 times 600 plus this portion of the slab plus أول بشر slab 4 645 times 100 أكاتا 645 times 100 645 أكاتا do PNC 600 millimeter square. Now find A naught 0.85 this value 0.85 this value A naught 0.85 this value شنكا أكاتا point is equal to 0.85 this value أكاتا 21560 millimeter square. Try to find pH is equal to summation x1 plus 1. Substitute here x1 go through this line P perimeter hoop go through this line أكاتشان بخد بتوين حسابك أكاتا 310 plus 610 times 2 plus 645 times 2. You can pass through this and find this the result. واضح؟ أكاتا C130 أمش غلطي كيف شوكيتي توين شايكن 3130 توين شايكن. Now we find parameters pH, outermost closed stirrups, Amando 0, where I go to apply this equation. V ultimate 250 10 to power 3 over BW 400 H D upon D over D 637 all square plus TU Panjaudu 52 10 to power 6 times pH 3130 over 1.7 times I naught edge times I naught edge, yes, I naught edge times this value I naught edge times I naught edge 3253600 square. Well, all is also square 253,600 square. This is must be less than 0.755 VC. We have VC. We found VC. This is VC 229.4, similar to the first example. 229.4 BW 400 D 637 plus 0.66 under the square root 28, and this value is equal to 1.783. This is must be less than 3.29. 3.29. This is okay, the section is okay. If this is more than this, we must increase the section. If this value is more than this, we must increase the section. We must increase the section, magnify the section. Even this is here is not required, this is less than this, even the section is okay. For applied shear and torsion. It's okay for applied shear and torsion. Now I go to design for stirrups for shear and torsion. Now I go to design the section 6. I go to design the section for shear and torsion. Design design stirrups. Design stirrups for shear and torsion. Applied shear and torsion. For shear, as we know, for shear, and we have the similar equation, AV over S is equal to same as previous example, VS, same VS, Fy transverse times D, and this is equal to same equation, same value, substitute here, same value 3.388 millimeter square per millimeters. IV over S, we write millimeter square per millimeter, IV over S. Per 2 legs. For stirrups, for 2 legs, as we know in the chapter of shear, we get for 2 legs if we use this equation. Now for torsion. In torsion, we use Tn, Tu, we have Tu, phi, Tn. Tu is, as we know, Tu is equal to 52, phi is equal to 0.75, Tn is unknown. We found Tn is equal to 69.3 kilonewton. Same as previous example. 69.3 kilonewton. Same. Now substitute in our equations. In this equation, Tn is equal to 2 A naught 80 over S. This is stirrups requirement for torsion times Fy transverse times cotan theta. Tn is similar, 69.3 10 to power 6 to A naught. We have A naught. 215,560. 80 over S is required, is request of the problem. Fyt 420 times 1. Then we found the stirrup required for torsion. 80 over S is equal to 0.383. 0.383 millimeter square per millimeter per 1 leg. Here per 2 leg. Per 1 leg. Per 1 leg. Per 2 legs. Here per 1 leg. Per 1 leg. Now total for a stirrup, total 80 over S plus AV over 2S is equal to 0.383 plus 0.388 over 2, and is equal to 0.577 millimeter square per millimeter. This is per 1 leg. 1 leg divided by 2. Since the shear reinforcement required for a stirrup divided by 2, this is per one leg. Now this we call the AV over T. AVT over S is equal to 0.577. This we call it AVT over S. What we know, we use phi 10. This is phi 10 millimeters. AV for phi 10 millimeters. AVT for is equal to 78 millimeters square for phi 10 millimeters. Now substitute here. Substitute here this 78. S we get S is equal to S 136 millimeters. If we take the effect of the slab into consideration, the spacing due to the load, due to applied shear and torque is equal to 136. In the example number 1, we get 1. We get some difference, some little bit difference between the results due to the effect of slab. Now, I check minimum. ساعة شنو؟ دقيقة. Okay. Now I go to check the section AS minimum. Now we have AS, we have minimum AS A T over S plus A V over 2S must be greater than 0.35 PW over FYT. Similar to the previous example, similar. Here we get 0.333 and S similar 234 millimeter. This maximum, first maximum. The second 80 over S, the second minimum equation must be greater or equal. Must be greater or equal 0.062 FC prime B web over Fy transverse 0.312, and the result is equal to maximum S is equal to 250 millimeter center. Now also we have maximum S, another requirement, pH over 8, pH 3130 over 8 is equal to 391 millimeters. 391 millimeters. Now we have this distance, we have this distance, we have this distance. This is from the loads, applied loads. Now this is control. This is control the spacing between the stirrups. This is control the spacing between the stirrups. Control the spacing. Now even therefore final decision we use stirrups 10 millimeters at this is control. It's better in practical point of view. ناحية عملي. Practical point of view ناحية عملي بتشان بكابين نابي صوت سوشاش بتشان بكابين صوتو بستو بينج مليمتر سنتر معناه ويا هاد فيلين بوستاكا ألين بوفورمانكا ألين we say use do bars do stirrup in do صوت بنجاملي in do صوت بنجاملي يعني 20 سنتيمتر دو دانا مودانين لا دو دانا مودانين لا 20 سنتيمتر دو دانا مودانين do for torsion and shear. This is 6-7 design for longitudinal reinforcement for torsion, for applied torsion. For applied torsion. واضحة؟ اشتكان بو دوباره تقريبا ما دام الستيب يكم x1y1 x2y2 مان زاني او كان يكربيتا x0 مان زاني x0 هرشو على x0 مان او كان يكربيتا واضحة؟ او كان يكربيتا. Now سكشنك چیە کات AL إذا TN چیە کات ئەکسات 2 A naught AL over PH F Y longitudinal times tan theta. This is tan theta. Tan theta. Now Tn akabachan. Tn is just to know 0.3 10 to power 6 2 A naught. A naught is noun. A naught is noun. Here A naught is noun. 2 1 5 5 6 0. A naught is noun. 2 1 5 1 5 0. 6 times AL is a noun. PH is noun. 3 1 3 0. FY 420. Tan theta 1. The only unknown in this equation A longitudinal reinforcement. This is coming from the load. Coming from the load. Chaniker 1198 millimeter square. إذا 31198 millimeter square multiplication for longitudinal reinforcement. Now we have also minimum. AL minimum check come 0.42. أبي تشيكي كيتو F prime C times ACP over FYT minus A T over S times PH times FY transverse over FY transverse over FY. إذا minimum AL أكاتا خفصة بنجاو نو مليمتر سكوير. This is minimum. The other minimum second equation for the minimum AL we have two equations. Minimum, it is similar but just we have minus 0.17 BWeb over FYT except AT over S we have this term, it is similar, and we get substitute here, we get 1436 millimeter square. Now minimum AL, from these two values we use the minimum, the less value. From these two minimum we use the less value. Then حفصة 759 millimeter square. This is minimum, and this is from the load. This is from the load, applied load, coming from the applied load. But this minimum, therefore this is final AL. Use AL. This is more less than applied, coming from the applied 8 millimeter square. Now this is longitudinal reinforcement. Then longitudinal reinforcement must be distributed along the section. Along the section must be distributed along the section. Along the section. Must be distributed along the section. Now we have stirrups here. This is the first. This 118 must 1198 must be divided by 3 space 1 2 3. Now firstly I assume using 3 layers, 1 layer or 2 layers or 3 layers. In each corner we must put a reinforcement. In each corner we must put a reinforcement. This is the requirement. In each corner of the stirrups we must put a reinforcement. Corner 1 2 3 4. And the spacing here spacing is B here, S1. This is S1. This is S1. Between this reinforcement, not up top, this reinforcement. This reinforcement. Now, this is divided by 3 is equal to approximate 102 أكاتا تقريبا 400 millimeter square for each layer. Top, longitudinal reinforcement. Top, mid height, or bottom. Top, mid height, and bottom. At top, we have 2 phi 12, 113 plus 400. It must be provided دوصد شصته بستو هشت بستو شش millimeter square at top. This must be provided at top. This must be provided at top. This must be provided at top. And divided by, this is divided by, we use phi 12. We use phi 16 millimeters. Do sub 200 is equal to use 4 phi 16 millimeters at top. 1 2 3 4. 1 2 3 4. We use 4 at tops, 4 5 16 millimeters at top. 1 2 3 4. We use 4 1 2 3 4. Now at mid height, ليرة at mid height ليرة أكاتشان رأسنا كات 400 millimeters. إذا use 2 phi شانزة millimeter. إذا this is 2 phi شانزة millimeters. Now at bottom we have 525 5 سبنج. هر یک کلوان اریا چنده 400 نوت. هر یک کلوان اریا چنده که 400 نوت. 5 کات 2500 2450 بزنم کات میلیمتر سکوئر. 2450 میلیمتر سکوئر. ونیا 2450 میلیمتر سکوئر زائدا عفوا هبينا بنسيناها plus 400 divided in 2 layers ياك دوسة layers ياك دوسة أبي توزيعي كي distributed along the section of the members. Longitudinal force must be distributed along the section of the members. أبي تابشي كي و plus 400 أكاتم زانم 2950 مليمتر سكوير و divide by 400 نوت 5 سبينج أبينين use 6 phi 25 millimeter at bottom. 6 1 2 3 4 5 6 phi 25 millimeter. 5 for bending, 5 for bending, the others for torsion. This is for torsion. 6 the others is for torsion. Now the remaining just it's required to check this spacing. Check of this spacing. This spacing is required to be checked. This spacing must be checked. How spacing is checked? How you can find this space? S1 in this way. 700 minus covers times 2 cover here 40 زائدا دا 40 زائدا دا for the stirrups minus 100. This is 100. We found 100. This is minus the spacing between this stirrups 100 minus 5 over 2, 16 over 2 minus 25 over 2. We get the spacing between this bar and this bar. We found the spacing between this bar, and this bar, this bar, and this bar, this bar, and this bar, divided by two spacing, one spacing, two spacing, and this is equal to 240 millimeters. 200 is equal to 240 millimeters. This is accept or not? This must be less than. This is accepted. This is 250 millimeters. 250 millimeters. This is accept according to the issue. In each corner we must be reinforcement. Here 1, 2, 3. This reinforcement is each corner we put reinforcement. Corner here. 3, 5, 12 millimeters. What is distance is more than 300. We must put another reinforcement here is equal to 4. 1, 2, 3, 4. In each corner here must be reinforcement. These are corner. Here the distance is more than 300. Just by eyes it's clear. This is 645. This distance is more than 300. زیاتر از 300 میلیمتر. مادام زیاتر از 300 میلیمتر ابي شیشه کن بچاو دیارم. های بچاو ابي شیشه کن راس دابرید. به شیشه کن. اذا ام 4 1 2 3 4 مان دار. و چکی diameter استرابا كمان زاني. diameter استرابا كمان زاني 5 وتمان دور رقمان هي يان 10 millimeter we use 5 or 0.042 spacing between the stirrup. Spacing the thing that is S is equal to 1 1 1 3 stirrup 136 from the calculation 136 millimeters 136 millimeters, and this is also more than 10 millimeters. Okay, this also is more than 10 millimeters. I cut it more than 10 millimeters, then this is also okay. واضحة؟ ليرة طوال ديزاين تورشنال زاني وبروبلمتان بقطان حليكا.